Hi, Assalamualaikum and a very good morning. So now we are in chapter 5, hydrocarbon, and we're going to focus on the subtopic of 5.2 alkene, part 3 of the video. So in this video, we're going to do some explanation on the addition reaction of alkene with the presence of hydrogen in the presence of catalyst. So alkene which have a double bond, for example like this, going to be add up with hydrogen in order to form carbon-carbon single bond at all of the carbon atom. So if they are adding with hydrogen, so hydrogen going to be add up here. Okay, and you can also do that with halogen, where halogen consists of chlorine-chlorine or bromine-bromine molecule in inert solvent, or you can do that halogen with water, or you can do that with hydrogen halide, which is example of HCl and HBr. Also, you can do the addition reaction using the acidified water. In part 1, which is the part I here, we're going to write the mechanism for the electrophilic addition of the hydrogen halides as well as the acidified water. So we're going to see two mechanisms in this video. Also, we're going to explain the formation of the product, which is according to the Markovnikov Rule, and this is going to affect the major product. Also, by the end of the video, we're going to see the product of the reaction between alkene and hydrogen bromide in the presence of peroxide, where this is going to be the anti-Markovnikov rule, which is the reverse of the Markovnikov rule that we're going to learn in this part. Okay, so this is the rough idea. So without any further ado, let us start. So for the addition reaction to the double bond will have this following characteristic. So double bond will consist of the pi bond and also the sigma bond, and by using the addition reaction, it's gonna form all carbon-carbon single bond. So the double bond gonna be broken down and form two new single bond. So by the end of the addition reaction, only one product is obtained. And the product obtained is a saturated organic compound, which refers to the carbon-carbon single bond. Okay, now if we have the structure here, where we have the structure of alkene and we're adding up with a substance X and Y, by using the addition reaction, X is going to be inserted in this region and Y going to be inserted at one of the other carbon. So you can also you can write it as X and Y here, or since they are symmetry, you can also flip to become Y and X here. So it doesn't matter. Now, we're going to focus on the addition reaction using the hydrogen gas. Okay, so this is known as the catalytic hydrogenation. Means that alkene will be reacted with hydrogen molecule in the presence of catalyst. So that is why the name is catalytic. And this happens at this required temperature here, which is at room temperature up to 90 degrees Celsius. So the double bond here going to be broken down, and one of the hydrogen going to be inserted here and the other hydrogen going to be inserted here. So if you were to draw it nicely, you will get to be the expanded structure to be an ethene. So from alkene, which is ethene, because two carbon double bond, it becomes an ethane when hydrogen is being inserted. Now we're gonna do the addition of halogen, which can be chlorine-chlorine or bromine-bromine in inert solvent. So this process here is known as halogenation because we are adding halogen into the double bond. So we have the carbon-carbon double bond here, which is an alkene, and then we're gonna react with halogen in inert solvent. So here is dichloromethane, which is example of the inert solvent. So in this case, we are going to be attaching here, and the bromine atom, another bromine atom will be attached at another carbon atom here. As before, the double bond going to be broken down to form single bond. Okay, same goes to this situation where at first here got one hydrogen and one of the bromine going to be inserted on that side and the other bromine going to be inserted on that side. So this one gonna be a single bond now. All right, so that's gonna be the addition of halogen in inert solvent. Okay, Now we're going to move on to number 3, which is addition of halogen in water. So the halogenation of an alkene carried out in aqueous solution, for example water, produce a halo alcohol called a halohydrin. For example, if we have an alkene reacted with the halogen, for example bromine gas, in water, this will produce and causes the Br to be attached with one of the carbon. Meanwhile, OH, which is the component of water, will be attached with another carbon. So how do we know OH going to be attached here or OH going to be attached here? So for this case, halogen going to be attached with carbon with a greater number of hydrogen. So in this carbon number 1, if I were to write it here, so carbon number 1 going to have 2 hydrogen. Carbon number 2 will have only 1 hydrogen. So Br going to attach with the carbon with a greater number of hydrogen. So Br going to be attached here. Okay. Meanwhile, OH going to be attached at carbon with fewer hydrogen. So OH, which is the component of water, going to attach at carbon number 2 here. Alright. And this is called a halo alcohol because OH is the hydroxyl functional group, and the class of the compound going to be alcohol, and because it contains halogen, because of the Br, it's going to be called as halo alcohol or known as halohydrin. Okay, same goes to the example here, because you know that here going to have 1 hydrogen here, right? So this carbon going to have 0 hydrogen, this carbon going to have 1 hydrogen. So the Cl going to be attaching at this carbon because halogen going to attach with carbon with greater number of hydrogen. Meanwhile, OH going to be attached at here. Now we're going to see the addition of hydrogen halides, or known as hydrohalogenation. Means that we are adding hydrogen and we also adding a halogen, which can be bromine, chlorine, etc. Okay, so the addition of alkene with hydrogen halide going to form haloalkene, and the reactivity of alkene towards the hydrogen halides will be better at hydrogen iodide because hydrogen iodide bond is the weakest. So the reactivity at Hi, okay, the strength of Hi bond going to be the weakest. So Hi is more reactive. Okay, let's say if you have the let's say if you have an alkene here, and then you have your hydrogen halide, so the hydrogen going to be attached at this side and bromine going to be attached at this side. And same goes to this case where we can change our halogen to be Cl in the presence of the solvent aluminum trichloride. So hydrogen can be attached here and chlorine can be attached here. So for this case, they're going to be no problem because carbon and carbon here will have 2 hydrogen on each side. Carbon 1, 2 hydrogen, carbon 2, 2 hydrogen. So you can add up H to this side or H to the other side. However, we need to follow the Markovnikov rule. So the Markovnikov rule stated that the addition of the hydrogen halide, which is HX, to the asymmetrical alkene, means that carbon-carbon double bond will have not having the same hydrogen atom. Here might have only 1, here got 2. So when there gonna be a case like this, the hydrogen atom of the halide gonna be attached with the carbon atom that has a larger number of hydrogen atom. Okay, to understand this better, let us look into the example here. So we have our alkene here, and this is the hydrogen halides. Okay, so according to the Markovnikov rule, the hydrogen must be attached at carbon which has a greater number of hydrogen. So this carbon gonna have 2 hydrogen, and this carbon here gonna have only one hydrogen. So the hydrogen of the halides gonna be attached at carbon number 1. Okay, and the Br gonna be attaching at carbon number 2. So this one gonna be our major product. Okay, kebanyakannya akan jadi begini. Tetapi there will be a cases where Br can attach to here and H gonna be attached to there, but it gonna be our minor product. Jarang berlaku. Alright. Now we're gonna look into the reaction mechanism. So for the addition of hydrogen halide, we need to know the mechanism. So we know that the carbon-carbon double bond is the electron-rich part, which is our nucleophile of the alkene molecule. So the nucleophile will attack the electrophile. Okay, so for the step number 1, we have the formation of carboxyl ion and the halide ion. So we have our alkene here, and this is our hydrogen halide. So we know that this is our nucleophile because it contains a lot of electron here. So what we're going to do is the nucleophile will attack the electrophile, and this going to break the bond in between the HBr, and the hydrogen going to be attached at the carbon which has more number of hydrogen according to the Markovnikov Rule. Okay, and the Br here will be having a negative charge, and this is going to happen very slowly. Okay, so heterolytic cleavage, so the 2 electrons going to be transferred to bromine. Now for step number 2, there's going to be a rapid reaction with the negative ion. So because now the bromine will become the negative charge, so now this is going to become the nucleophile, and this is going to become the electrophile. So we can draw it again, where we will bring this structure to here. So we can, this happen at a very fast pace, and we can draw the double bond, the lone pair, and attack the electrophile. So here going to be the nucleophile, and here going to be our electrophile. So nucleophile which have more number of electron going to attack to the region which has less number of electron, and this process here will allow the bromine to be attached. And as what you can see here, the hydrogen will be attached to the carbon which has more hydrogen atom attached to it, and this follow Markovnikov rule. Okay, so this for the addition reaction of hydrogen halide, it is very easy because it only contains 2 steps. All right, now we're gonna do another reaction, which is reaction number 5, which is addition reaction with acidified water, where when we add water, it basically refers to hydration. Okay, hydra maksudnya air, tambah air kepada alkyl bond tadi. So let's say if we have an alkene and we add with water at the acidified condition H3O+. So the hydrogen gonna be attached at carbon which has more number of hydrogen. Okay, so carbon sini ada 1 hydrogen, carbon sini has no hydrogen. So the hydrogen gonna attach with the carbon which has more number of hydrogen atom attached to it, and this is based on the Markovnikov rule. So hydrogen akan masuk ke sini. Meanwhile, the OH gonna attach to that side. Alright, so this one gonna be our major product, and as I mentioned before, there also be a probability of some OH gonna go here and H gonna be here, but this is very likely to happen, jarang berlaku, and this gonna be the minor product. Alright, so another example, still the same one, carbon. This carbon will have more hydrogen atom attached to it, so the hydrogen gonna attach with the carbon which has more number of hydrogen atom, and this gonna be our major product. OH going to be attaching here, major product, and this going to be our minor product. So from alkene, it going to produces an alcohol. All right. Now we're going to see the reaction mechanism for the acid catalyzed hydration. So for the first step, we need to form the carbocation. So we know that the double-double carbon bond going to be our nucleophile, where the double bond going to attack the electrophile here, and this going to break the bond in between H and O here. Okay, so the hydrogen going to be attached at this carbon, because this carbon contain more hydrogen atom. So it's going to be CH3 here, and this going to produce a carbocation, which is tertiary carbocation, and this going to produce water. Okay, so plus OH H dot dot and double bond here, because this is where water is being produced. So now from the tertiary carbocation, we're going to try it again here. We're going to form a protonated alcohol. So what we can do here is, because of the reaction of water, the nucleophile of the water, because it has more electron, going to attack the electrophile here. Okay, so whatever arrow that you can, upwards or downwards, it is still okay. And this is going to produce a protonated alcohol. Okay, so basically you bring the whole structure of water into the system here. Okay, now this is going to produce a protonated alcohol. Now you're going to eliminate the H plus, or known as the deprotonation. So the water that you have in the surrounding will attack one of the hydrogen, either that one or that one, in order to break the bond, in order to form an alcohol. So I can use the lone pair here and attack this hydrogen, and this is going to break the bond in between H and O, and this is going to produce an alcohol here. So two electron going to be transferred into oxygen, and this is going to form an alcohol, which is our major product. And this is known as 2-methyl-2-propanol. And as the result, the water here going to be produced as before again, which is H3O+. Alright, and this is the summary of what I have shown just now. For step number 1, we add the hydrogen into the system according to the Markovnikov Rule. So you're going to be CH3 here, and this is going to produce a secondary carbocation. And then the water that is produced from this side going to be used to attack the carbocation, because this one is positive, and then which act as an electrophile, and then this one is the nucleophile. And then when it is attached to there, we use another water molecule in the surrounding to remove the hydrogen, and then this is going to produce the alcohol that we wanted. Okay, so this is the summary that I have shown in the previous slide. So now we're going to look into the reaction of alkene, where it follows the anti-Markovnikov rule. So this happens in the presence of the peroxide, which is ROOR. So ROOR here means that R can be either hydrogen or it can be carbon chain. For example, CH3. So ROOR here can be HOOH, or can be CH3OOCH3. Okay, so in the presence of peroxide, for example H2O2, where this refers to H2O2, the addition occurs in an anti-Markovnikov manner. So the hydrogen atom will add to the carbon atom in carbon-carbon double bond with the less number of hydrogen. In Markovnikov, the hydrogen going to be added to the carbon which has more hydrogen. But now because it's anti, dia adalah terbalik, the opposite. Okay, so we should add the hydrogen at the carbon which has less number of hydrogen atom. Now let's look into the example here. So we have carbon-carbon double bond here, this carbon will have attached with 2 hydrogen, correct? And this carbon will have 0 hydrogen. So when there is a presence of peroxide, the hydrogen gonna be attached at the carbon which has less number of hydrogen atom, and the Br here gonna be attached at this side. Okay, and this is because we follow the anti-Markovnikov manner in the presence of peroxide. Okay, another example is here, where when we react with HBr and with the presence of peroxide, the hydrogen gonna be attached with a carbon which has less. Okay, this carbon here gonna have only one. This carbon here gonna have 2 hydrogen. So H gonna be attached at this point. Okay, so H gonna be attached here, Br gonna be attached there. So according to anti-Markovnikov rule, hydrogen atom added to the carbon with less hydrogen, which is the major product. Now, another example here, we have carbon which attached with 2 hydrogen and carbon which has none. So hydrogen gonna be attached to the carbon which has none of the hydrogen atom. So it's gonna produce hydrogen here and Br at this side. Okay, so I think that's all for today's video. See you again some other time. Bye.